Depending on your outlook, humans are either just beginning our foray into technological civilization or coming to the end of it. Either way, one thing is clear. There is still massive amounts of room left for technological development, especially in space. The possibilities are mind-boggling for our own future, leading some to speculate that the best way to find evidence of other civilizations in the universe is to ask ourselves what could be done on a scale large enough to be detected at a distance, and how we might look for that in our studies of astronomy. The same goes for anything we might do and how that might be spotted by others. So here are 10 astroengineering projects, among many, that we may someday build, or see that someone out there already has. Number 10. Terraforming. It could certainly be said that we live on the surface of a technologically altered world, but it's already been altered and effectively terraformed long before we arrived. Earth would look very different today had there not been one aspect of it that had the capacity to dramatically change this planet into something it wouldn't normally have been. It was life, and somewhat early in the history of life on this world, it began to change the atmosphere, and most important of these changes was the Great Oxygenation Event. This event occurred when photosynthesis evolved and allowed the early microbial plants to begin to oxygenate the atmosphere. This had profound effects on this planet. One effect was on Earth's life previous to the event. It poisoned a lot of it. But there was also the iron. In space, iron generally exists in metallic form. Iron meteorites that fall to Earth are full of iron inclusions, or even entire meteorites made up mostly of metallic iron. But it doesn't stay that way for long on Earth's surface because of oxidation and ultimately life. So on the surface of the Earth, iron likes to exist as rust. Though deep down it does still exist as a metal, then that leads to something scientifically odd and rather obscure. Other than iron humans extract from ore on Earth technologically, there is actually one other possibility for metallic iron on the surface of the Earth. It's called telluric or native iron, and it's extremely rare, found only in a few places on Earth, and is nothing like normal iron we extract from ores. This kind of iron is found in deposits of rock, and is more like meteoritic iron than earth iron, so much so that it forms crystalline patterns, called a Widmanstätten pattern, that is otherwise seen on Earth in iron meteorites. It is also high in nickel, as much as 3%, though that's still lower than is typical for iron meteorites. This was such a weird state of geological affairs that for decades mainstream science did not believe this iron was from Earth, and believed it had to be of meteoritic origin. Turns out it's not. It's from here, and while extremely rare, it does still represent metallic iron on or near the surface of the Earth. But for most of Earth's surface iron, it was long ago locked up in oxides by life's oxygen. In short, you could say that one form of very non-human, non-technological life terraformed this planet billions of years ago, changing it biologically, geologically, and indeed astrobiologically, since any civilization in the galaxy looking at this strange exoplanet around a relatively calm star is going to see those weird oxygen levels and know that something unusual is going on here. But at any real distance in the galaxy, relatively speaking, they won't know about us as a civilization, even though, on a rudimentary basis, we are already artificially terraforming this world ourselves. Plenty of what we do as a civilization is now visible from a distance, at least with a big enough alien telescope, from our radio transmissions to our artificial lighting to our own changes we've made to the atmosphere. Even artificially produced chemicals like CFCs are visible. Should we see other exoplanets bearing these kinds of signatures or just odd levels of oxygen, we could infer that life is there. And if we saw certain exoplanets that have no plausible way to exist as they are, in conjunction with artificial chemicals like CFCs, we would know that someone is terraforming that world. What their motives are for doing so, however, may not be all that clear. For us, the obvious terraforming projects we might take on beyond Earth would be Venus and Mars. It would be an unbelievably huge undertaking to make either habitable for humans in a capacity better than they are right now, and it would take a very long time, but it is possible in principle. If a civilization were watching this star system over a very long period of time, at least tens of thousands of years, they would see one habitable planet, and then two others becoming increasingly habitable when they shouldn't. If over even longer periods of time they saw exoplanets and other nearby star systems becoming habitable, it would be obvious that there were spacefaring terraformers here. Number 9. Alderson disks. Imagine living on something like the rings of Saturn, but not as a loose debris ring, but rather a solid ring encircling not a planet, but a star. This would be a world that was forever in twilight, and with the ring being so unbelievably massive that it generated its own gravity like a planet, but far, far bigger in scale and available surface area. You might know that thousands of miles beneath you, another populated side of the ring existed upside down from your perspective, though they might think the same of you. This sort of platter world with a hole cut for a star is usually termed as an Alderson disk, and has featured to a degree in science fiction, but it's really more of a thought experiment than anything that could ever be built as far as we know. In fact, current thinking is that such a structure would collapse and roll in on itself into a torus due to gravity. That's if it could be built anyway, since the matter needed to do it is at least several stars worth of material, if not more, and far more than what's likely to be found in most planetary systems, and certainly more than our own. So while we will very likely never build such a disk, we also don't know what alien civilizations would and would not do. So if one of these things ever were built and somehow maintained, it would be fairly obvious to anyone doing astronomy in the galaxy once they spotted it. So far though, no one has ever seen any evidence of an Alderson disk, and in this case, it would not be surprising if we never do. Number 8. Star shades. What length would a civilization go to in order to preserve itself from a catastrophe of cosmic proportions that they could do nothing about except try to mitigate the effects of it? Imagine if it were our own civilization in this position, where we know that some catastrophe, say a supernova, were imminent and nearby, and we either simply go extinct when it explodes, or do whatever we could to shield ourselves from it. Which would we choose? In reality, so long as we had the time, we could probably mitigate most any threat posed by the universe at large. This could be deflecting an asteroid on a collision course, or building a giant shield in space to block the effects of a nearby gamma ray burst. If the shade and configuration were large enough and in someone's line of sight, then it would be visible as a technosignature. And it's worth noting that we may have little choice in eventually constructing such a shade. Our sun is increasing in luminosity over time and will eventually overpower the surface of the Earth, boil the oceans away, and cause the extinction of all surface life. But if we had a shade in place to block sunlight, we might buy some time, conceivably even millions of years. But certainly not permanently, given that the sun will eventually swell into a red giant stage, and no shade will protect Earth from that, though it would certainly be an interesting, though sad, technosignature if we ever detected anyone out there in the galaxy building such emergency structures. Perhaps they might be the most likely type to see. Absolute necessity is a great motivator after all. But in the end, you don't get out of this universe alive, and there are things that could happen that there are simply no defenses against. One of these is if the universe tunnels to its lowest vacuum state, if it's not already there. That would fundamentally disrupt everything, including potentially the structure of matter itself. Not much could be done about that, and indeed we'd have no way of knowing about it until it hits us. Or there is the death of the universe itself, whether that comes from old age and the deaths of all stars, or the decay of the proton, if that ever happens. In any case, there comes a time for our lights out, and there is very little anyone in the universe could do about it, no matter their level of astroengineering. Number 7. Arranged bodies. One of the most recognizable megastructures, at least a megastructure of sorts, would be the artificial arrangement of stars. This can take different forms. If an alien civilization, for example, needed another star, say for power generation, but didn't want it all that close to their own star system as not to gravitationally disrupt anything, they might arrange one or more stars within a light year or so of their home system for use. If they did this enough, and in a conspicuous arrangement, this would be visible to the rest of the galaxy, at least eventually. But there's also the possibility of arranging the planets or artificial structures in your own star system to your advantage. One variation of this idea is the Klemperer rosette, where ideally you can arrange 5 gravitational bodies together at their Lagrange points orbiting a common barycenter. and create a more or less stable system. There are other possibilities in this kind of arrangement, though they would generally be less stable long term. Regardless, anything like this would require maintenance and would be very unlikely to occur in nature. If we ever saw such an unlikely configuration of bodies, or if we built one and someone else saw it, it would be very difficult to dismiss it as a chance occurrence. Number 6. Niven rings. In 1970, science fiction author Larry Niven conceived of an idea in his novel Ringworld where essentially a giant habitat ring encircles a star, in this case with a radius the size of Earth's orbit. He envisioned a truly vast landscape within the ring, where mountains would flank the sides of the habitat in order to hold in the atmosphere, and with a capacity to support trillions living on the interior surface, to a tune of 3 million times the available surface area we have here on Earth. To build the ring as he envisioned it, you'd need the materials available in a large gas giant. If we did it here, we'd need to disassemble Jupiter. The interior habitable area of the ring would then be customizable, and could be dedicated to anything from vast farmland, managed forests, or even shallow oceans. This idea is very similar to a Dyson sphere, and indeed really is just the equator of one, where gravity can be simulated, with the rest of the sphere, which would be less useful, cut away. Building one of these is problematic, however, and may in practice be impossible. We won't be building one anytime soon. Problems with the idea include gravitational instability and drift, which is not good when you're near a star. Things like attitude control are possible here to mitigate these effects, but again, practicality is a problem, and even though it may be remotely possible to do, it's never worth it in comparison to other methods of settling space. And there's Jupiter. It may simply be too useful as it is for us to disassemble. But perhaps the biggest challenge of Niven rings, and indeed full-on Dyson spheres, is that we can't envision materials strong enough to be able to handle the stresses put on such a large structure. But it's also been suggested that somehow, and I stress somehow, manipulating the strong nuclear force might allow for a material that could handle the stresses, and this leads us to the technosignature. A Niven ring would be visible in the light curve of a star and is in principle detectable at a distance. While it is very unlikely we would ever build or see evidence of such a structure, if only for reasons of utility and practicality, another problem being one catastrophic failure anywhere on the ring might cause the failure of the entire thing, if we did see evidence of a Niven ring, it would be extremely telling, perhaps one of the most telling megastructures we could detect. It would speak of possibilities within engineering, chemistry, and physics that we simply know nothing about yet. It would seem almost magical, a puzzle to be dissected over centuries to figure out just how they built the ring, and also figuring out why. Such a thing might provide a roadmap to developing those technologies ourselves, so that someday we might build our own ring, for some reason. Number 5. The light of an ecumenopolis. The idea of an entire planet being completely paved over and occupied by a city civilization has been explored in science fiction, 2 examples being Isaac Asimov's Trantor and George Lucas's Coruscant. While a fun thought, or maybe not so fun on second thought, these types of enormous settlements face likely insurmountable problems, not the least of which would be unbearable waste heat. But you could do a partial ecumenopolis fairly straightforwardly. In fact, we've already done it with Earth, and large sections of planets could be devoted to such things as energy collection. If these kinds of projects were sufficiently large, they should be detectable from a distance, either through seeing telltale signs of artificial lighting or energy collection technology, like vast arrays of panels on the surfaces of exoplanets. And if someone were close enough, and they'd need to be really close, they could detect our own artificial lighting here on Earth. But the question remains if anyone builds cities that large, or if doing so stops making sense at some point. It's also possible that as a civilization moves into space, it may no longer be advantageous to maintain such a huge presence on their home world. It may simply be more advantageous to keep most of your civilization in space, and let your planet largely return to nature and continue its natural development, or guided development of life. Maybe someday it might produce even more intelligent species that you can integrate into your space society. This is the core of Jeff Bezos's particular vision of space settlement, so this kind of scenario may be closer rather than further in the human future. Number 4. Scatterthruster. Stars change, including our own sun. As it ages, it will become increasingly hostile to life on Earth, eventually ending all of life on this planet, as I mentioned before. But what if we could do something about it? One option is to not just find another star system with a habitable planet to settle, but rather move Earth to another star entirely. This employs a concept called a scatterthruster. The idea is simple. You build a giant mirror in the shape of a half sphere or similar at the point where the gravity of the sun equals the outward pressure of its radiation. From this point, the sun's own radiation will begin to push it in whatever direction we wish, and thereby taking all of the planets, including Earth, with it. It would then be a matter of moving the solar system just so as to have another star capture the planets. Of course, it's not really that simple. You'd need to dissipate heat from the thruster into space to keep the whole thing from melting. And even to build it, you'd eventually need to disassemble Mercury, even though the thickness of the material involved need not be much more than foil. And then you could really only place it where it wouldn't disrupt the planets of the solar system, specifically Earth, putting limits on just what direction you could go. Probably too much to ask. And just getting something like that moving would take immense amounts of time, and even more time to make the trip, as this method is rather slow. But we happen to have that kind of time. The sun isn't going to start to bake the planet for at least hundreds of millions of years, and we may not have to go that far. Stars routinely pass close to the solar system on long timescales. It would be a monumental undertaking to be sure, but if we're all going to go extinct at the hands of the sun anyway, then it might be an option in the far future. But a better option might simply be to migrate Earth away from the sun using asteroids passing by and nudging it outward to keep within the sun's expanding habitable zone. That too might be visible long term to an alien civilization periodically checking in on the star system. And then there's the question of dangerous stars. If we or someone else were located uncomfortably close to a star that may go supernova, say the stars are passing by each other at the wrong time, then building a scatterthruster to kick out the dangerous star might be the only option. If someone is doing this out there somewhere, it should in principle be easily detectable through the system in question's odd motion, infrared radiation screaming off the thruster, and if it happens to eclipse its star from our perspective. Number 3. Stellar lifting and energy production. Perhaps the greatest and perhaps the most visible thing one could do in this universe is to collect resources. We very much already do this, and always have. For us to even be here, all of our ancestors, human or otherwise, collected and used natural resources on Earth, from water to other life itself. As civilization developed, we increased our activities in this regard, from mining and refining metals to drilling for fossil fuels. As we move out into space, there we run into another set of resources. It becomes a bit cumbersome launching materials from the gravity well of Earth into space, so the resources available on places like the Moon and the asteroids come into play. But there is also the energy of the sun, which allows us an unbelievably powerful free energy source to collect from, to say the least. We already use the sun heavily. Life on Earth depends on it, and we increasingly collect solar energy for use in our civilization. As we grow, this will become more prevalent, and eventually it will become feasible to directly collect energy from the sun in space on a large scale, which we do now on a small scale with our solar-powered satellites and probes, but could do on a much greater scale by progressively building energy collectors in space to create a Dyson swarm to power Earth itself. Dyson swarms should be detectable as technosignatures if they are extensive enough, but at some point you can take this a step further, harvesting materials from the surface of the sun itself. Known as stellar lifting, this essentially comes down to mining materials from the surface of a star. There are several hypothetical ways to do this, and several reasons you might. One reason is if you needed a lot of hydrogen and didn't have a local source such as a gas giant for it, or other elements from stars. Another would be to manage your star's brightness, a possible future option for us, or manipulate the lifetimes of stars, or gain materials to build custom stars. All of this activity, if someone were doing it, might be evident from afar as technosignatures. And there may come a time when anyone that may be left in the universe must do these sorts of things. As the universe dies and resources and even stars themselves become increasingly rare, and the expansion of the universe increases the loneliness that comes at the end, these sorts of projects may be all that's left to keep the universe going. Perhaps the last major stars of the universe might be artificial ones, or at least altered ones. But in the end, no matter how much you try to extend things, the end does come. Number 2. Missing galaxies. In 1964, Nikolai Kardashev speculated that there could be 3 types of civilizations in the universe: those that can control the energy of their planet, Type 1, those that can control the energy of their star system, Type 2, and those that can control the energy of their entire galaxy, Type 3. While there have been numerous variations on that take, a Type 3 civilization offers us a speculative option for a civilization that would be both extremely powerful and extremely visible to other nearby galaxies. One way a Type 3 civilization might control their galaxy is through the use of energy collectors ranging from Dyson spheres to Dyson swarms. These would in turn block a lot of starlight, perhaps even making the galaxy nearly invisible in the visual spectrum, as most stars within it are encased. But not in the infrared spectrum. Any type of structures of that nature are going to emit heat. So the possibility here is that we might search for infrared signatures of galaxies that aren't as visible as they should be in the visible light spectrum. We might also look at things like reddened galaxies that appear to have a dearth of large and dangerous stars that might be of artificial origin. Just kick out the bad stars out of the galaxy or engineer those stars into safer, smaller, more long-lived types. Approaching Type 1, it's hard to envision our civilization needing the available energy of the entire Milky Way. And indeed, if we ever did get to that level, there may be others out there in the galaxy that might have an issue with it. Because of that, it's hard to envision any civilization taking such a massive step, but there is a time where they may, as the universe ages. The available stars for energy production will become less and less, eventually reducing down to red dwarfs and ultimately blue dwarfs along with the remnants of stars. In such a case, artificial stars and grabbing up whatever energy is available might become feasible, important, and maybe even inevitable. Number 1. Simulated reality. Perhaps the greatest engineering project one conceivably could do is engineer your own universe. Much has been written about this in science fiction, where some kind of separate universe is created unintentionally or for the benefit of its creator. Even in science, the concept of other universes exist, either through parallel universes in the many worlds interpretation, or bubble universes that float like a kind of foam in the multiverse, and might even interact with each other. Harnessing the power to create actual new, perhaps even custom universes is beyond anything imaginable. It's true Clark tech, where it is indistinguishable from magic. But there is another way to create a universe, at least a de facto one. That is through something like computer simulation. While it's clear that within our own universe, to simulate another universe down to every detail would require more computing power than the rules of the universe allow, it could only ever be, at best, a simplified approximation. It's also unclear whether our universe is being simulated from the outside, and since we don't know the rules of what outside might be, it remains on the table that we live in a simulation of some type. Outside of creating an entire multiverse, a simulated universe, should this be a simulation, is about as big of an astroengineering project one can contemplate. While I don't think we live in a simulation, it does provide an answer to the why question of the universe. It could exist as an ancestor simulation for someone to see how their own universe once was. Perhaps they might even enter such a simulation from time to time and see how things are. But a universe that isn't a simulation loses that factor of why. It doesn't need a why. It simply just is, and perhaps that's the most disconcerting notion in the entirety of existence. But if we did ever somehow determine that this universe is a simulation, then that could be the biggest technosignature of them all. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently observing the large pumpkin sitting on my kitchen table. What if the universe is a pumpkin, and we're just on the messy, seedy inside, and outside is a well-organized kitchen with pie-making capabilities? Very disturbing, and be sure to check out my books at your favorite online book retailer, and subscribe to my channels for regular, in-depth explorations of this amazing universe in which we live.